derivatives. Now, today we're not going to be evaluating these. All right. Tomorrow we're going to talk about evaluating them and finding them like at a point. What is the derivative at x equals 0? What is the derivative at x equals pi over 4, pi over 2, pi over 6, pi over 3? So the unit circle is going to be kind of important. We're going to talk about how to utilize that tomorrow in regards to evaluations. I'm not trying to have you memorize them, so I'm not going to give you a full background in terms of the unit circle. It's something that you would have covered in Math 3. Something that you can cover over the summer, and we're not going to get into the nitty-gritty of why for right now, but how to be able to do it is the most important thing without a calculator, because you need exact answers. So as a quick review, okay, just in terms of the rules of what we've learned in terms of a function derivative, we've learned that the derivative of a power function, x to the n, is equal to n times x to the n minus 1. It's been like pulling teeth for you, and I say, hey, how do you take the derivative of this function? And the only rule was always like, bring the number in front, rewrite what we have, subtract the power by 1. It was like pulling teeth the last few lectures, when that was the only rule that we did. And every time you took a derivative, as long as it was in a function form, that was the only rule that you had to use. Bring down the power. Now, today, if you haven't mastered by now how to bring up number down and subtract the power by 1, well, now it's going to get a little bit more complicated, because now we're going to introduce a new rule. And the rules is not too bad. So a lot of the times, though, we need to just recognize it. So we also have derivative rules. And for our derivative rules, we had the constant, which was that the derivative of a constant is equal to 0. We have the linear, which these are both subsets of the power function. The derivative of mx is equal to m. We had a constant multiple. The derivative of a constant times a function is equal to the constant times the derivative. We had the sum and difference that we've learned, which said the derivative of a function plus or minus another function is equal to the derivative of that first function plus or minus the derivative of the second function. We have product rule. The derivative of a function times another function is the derivative of that first function times the second function plus the derivative of the second function times the first function. We have the quotient rule. The derivative of a function divided by another function, I'll review here, is equal to the derivative of that top function times the bottom function minus the derivative of that bottom function times that first function, all over the bottom function squared. And finally, we have the chain rule, which is that the derivative of a function with respect to another variable is equal to the derivative of that function times the derivative of the baby. And as a subset of the chain rule, we also technically had the power chain rule, which was such that the derivative of u to the n was n times u to the n minus 1 times du dx. But that's really just a chain rule being applied. All right. So these are all rules that, as of right now, you should all know. We've spent multiple lessons. We spend 2 days basically learning each time we introduce a new rule. We spend multiple days, not just a single day, and moving on. We've gone at half of the pace that I've gone for most of these topics. We've slowed it down into about half of what we would normally do, because remote learning, and I also want to put some bigger, more emphasis and give you the time. And if you've been reviewing it, it's going to click. One of the weird things about calculus is that oftentimes the material doesn't click and like, oh, I can just start doing it naturally without making efforts, becomes instinctive until after we finish that unit. It happens all the time. And it's one of the things that kind of can get frustrating to some students, because once you're no longer stressed about it and you're moving on and you're stressed on a new topic, everything starts coming together. Man, you're going to be like, man, I wish. It happens every year. The entire course is like, man, I wish I was doing derivatives again. Things were so much simpler and easier when we were just taking derivatives. Why can't we just take derivatives again? That's what happens year in and year out. So derivatives are mostly algorithmic. They're typically, the same problems over and over and over. You just have slight differences, and you just have to make sure that you're taking your time and recognizing what you're doing. Okay. So now we're going to talk about trig derivatives. So there are 6 trigonometric relationships. There are 6 trig relationships that you would have learned in a previous course. The relationships are sine, cosine, tangent, secant, cosecant, and cotangent. All right. Sine, cosine, and tangent are the big 3. They're the ones that you're going to see most common. They're the ones you're probably going to see on all your homeworks tonight when you're dealing with delta math. You're probably going to see sines, cosines, and tangents as your functions. We can go on in terms of where we will review later on when we talk about applications of sines, cosine, and tangents. The actual relationships to the hypotenuse, adjacent, and opposite, adjacent, and hypotenuse sides of a right triangle. So there are relationships of that. Right now, though, we're going to just focus in on the rules. Basically, the things that you just need to memorize, and it just becomes part of your algorithm that you have to build in terms of, like, if I see this, then I do this. If I see that, then I do that. So the big 3, and the rules are, and you can just memorize them. The derivative of sine of x is cosine of x. It's a function. They're functions as well. The derivative of cosine of x is sine of x. Is negative sine of x. And the derivative of tangent of x is equal to secant squared x. Now, it should be noted that secant of x in terms of is the same thing as 1 over, is the reciprocal to cosine of x. Cosecant of x is the reciprocal of sine of x. And cotangent of x is the reciprocal of tangent of x. It should also be noted that tangent of x is the same thing as sine of x over cosine of x. That's just algebra. That's just trig right there. So in other words, the derivative tangent of x can also be considered as 1 over cosine squared x. Now when you see secant squared x, just like the function notation, it means secant of x times secant of x. And I know you're saying, well, how am I mean, I haven't learned, or it's been so long, I haven't done trig, well, you know, I'm very confused. If you have no clue about what anything is on trig, then you need to get over to office to office hours, or more importantly, you're going to get over to tutoring. All right, I know they spent some time going over trig and Eric has been working and has plans to, you know, really focus on that unit circle. You need to review it as much as you possibly can. But you can get by, you can do the entire homework without knowing exactly what they are, and just memorizing for the time being that they are, the derivatives are what they are. Now, I want to note here, I can prove these using the definition of the derivative and trig properties. But I won't. But I can. So the biggest thing is, if you're wondering, why is the derivative of sine of x cosine of x? Well, I'll show you the proof. If you come to office hours, I'll do the entire proof with you if you would like to. And it really revolves around a lot of stuff that you would have to learn in trigonometry with the sum and difference rules of trig. The sine of a plus b is equal to the sine a cosine b plus sine b cosine a. Cosine of a plus b is cosine a cosine b minus sine a sine b. It utilizes those properties along with the definition of the derivative. If we had more time, I find it very beneficial so that when you go off to college, you have deeper understandings, and you can really prove it to, you know, when your professors in college try to throw that out to you, if they do, depending on the level university you go to. There is some importance to it, but hey, I teach the summer at MIT to incoming MIT students every summer, and I can tell you that, you know, 80% of the students who are even in my top course don't know why the derivatives are as they are. They just know that they are. It's, you know, so the basic form is, this is the derivative because it is the derivative, and that's, I don't like that. I'm not a fan of that, but it works for us. All right. The other derivative rules. We have the big three. This right here is the most important part. If you leave today with anything, that is the most important part, no matter without a doubt, that you need to have. Of course, we're going to add some chain rules into it. So trig, and I'm going to write it. Yes, you're writing down the same thing. Yes and no. Trig derivative rules. All right. The derivative of sine of u is equal to, and this is cosine of u times du dx. This is using the chain rule. The derivative of cosine of u, there's a baby, is equal to negative sine of u times du dx. The derivative of tangent of u is equal to secant squared u times du dx. The other rules, the derivative of, and these are the other rules for the other three, the derivative of secant of u is equal to secant of u tangent of u times du dx. They're memorizations, all right? They're memorizations. Derivative of cosecant of u is equal to negative cosecant of u cotangent of u times du dx. And finally, the derivative of cotangent of u is equal to negative cosecant squared of u times du dx. The entire day boils down to this. Now, we might utilize some of those top rules as well that we did in the review. We might do a product rule, a quotient rule. We might do a chain rule where the trig function is the baby. So these are the rules, but problems are never just as simple as what's the derivative of sine x. We're not going to ever ask you that. We're not going to ask you on the AP exam straight up, what's the derivative of sine of x? Oh, because that's just a memorization. Oh, cosine of x. There's literally nothing you do. It should almost be like right off the top of your tongue. Not today. Not today. You're first seeing these. You're going to want to have this right in front of you. I would say that basically this part right here.
Mister, why give it that?
Because you need them. These are your rules.
No. How the call you negative CS squared?
I don't know what CS. You mean secant?
No, that's secant.
All right, you got to use proper vocabulary on this one. What about it? What about secant squared?
How the equal negative secant squared u du dx?
There is no negative secant squared.
It's a negative CSC squared.
Negative cosecant squared?
Yeah.
So cosecant.
Cosecant.
I can prove it to you using a definition of the derivative. If you would like to come to office hours, I can prove it to you.
So, So yesterday I used the office hour, but you never started the Zoom.
That what?
Yesterday I go to the office hour and for your class.
No, you didn't. All you did was email me.
Oh, email first. Okay.
You never came to office hours. I'm in office hours. I was office hours from 1:50 to 2:35.
Yeah, I was to the office hour.
No, you didn't. You didn't go to the office hours link.
I didn't.
No, you did not. 100% guaranteed you did not. So I am in office hours every day. Office hours is a different link. If you're trying to come into AP Calculus or AP Statistics, that's not office hours link, because that wouldn't make any sense, because I have 4 different classes where all 4 classes have to go to each other. So those are the rules. Those are what we memorize. There is no excuse for not being able to look at this page for now and getting them. And what has to happen in calculus is that you need to memorize these ones. All right. So these need to kind of get to memorizations, and utilize proper vocabulary. I will not respond to cos, sin. I will not respond to those. It's sine, it's cosine, it's tangent, secant, cosecant, cotangent. You need to make sure that you're stating them as such, because it's very important that you understand that they are functions, they are operations that are being done. They're not just random letters being streamed together. So you should be able to have this, and you're gonna look at this page. You should probably look at this page as you're doing your homework tonight. If you want to challenge yourself, you might want to not look at it and try to do it without looking at them. It's a little bit challenging, but I think you can do the Delta Math assignments. And I think if you want to, really try to put yourself in the forefront, you're not looking at these. By Monday's lesson, you'll have it. So we're gonna continue, like, basically tomorrow we're gonna talk about doing the same type of functions, but evaluating them, tangent lines and stuff like that. That's gonna be tomorrow. And then Monday we're gonna kind of do a big mix. It's gonna be like everything. That's gonna be giving you some more tougher problems in practice that are gonna be trig, that are gonna be products, that are gonna be powers, a lot more babies within babies and switching it off. Example. Find f prime of x. Now, all of these problems are going to typically utilize other rules as well. Constant multiples still apply. Constants, sum and difference, products, quotients, chain rule, they're all there. Let's start on our examples in our most basic form. F of x equals 5 cosine of x. What is the derivative?
Is it 5 negative sine
5 times negative sine, yeah,
of x?
of x. As your first day learning it, I'm happy with this, more than happy. How can I clean that up, though? Let's clean it up just a little bit.
I don't know how.
5 times negative sine of x. How do I clean that up? What's another cleaner way of saying it? Simply negative 5 sine of x. All right, because it's what that negative means. It's like negative 1. So a positive 5 times a negative sine gives you a negative 5 sine of x. That's just, you'll never see the answer as 5 negative sine. And eventually, I hope that you'll realize, oh, the derivative of cosine is going to be negative. So my answer is going to be negative 5. And you'll see me often jump from here to here. But the rule, utilizing the rule of just let me look at the rule and let me copy it down, that's what we need to be able to do, just what Farida had just done. B. F of x equals 5 minus cosine of x. What is f prime of x? And if you want to do it step by step and doing all of it, like in terms of just straight up copying down the rules, perfect. And so some of you might be able to jump directly to the answer. Good. We're not trying to get there yet. It's not our priority. But what's the derivative of 5 minus cosine of x?
Does the minus sign make the derivative positive?
Correct. So it's a negative, right?
So it would be 5 times.
Nope. No times. There's no times. This is 5 minus.
Oh, plus.
So yes. So it's going to be plus what? Sine of x. And in reality, we don't even need that plus symbol. We can just say it's sine of x. Now, if you were taking it step by step, you would have done 0 minus parentheses negative sine of x. But that's just 0 minus is a plus, so you just get plus positive sine of x. So the derivative of that would be 0, because the derivative of 5 is 0. It's not a constant multiple, it's just a constant. Minus a minus, which gives me a plus sine of x. Example C. F of x equals sine of x squared. Oh, actually, no, wait, I'll get there. Sine of 5x.
Is it oh,
Yeah, go.
okay. Would it be cosine of 5?
Close. Remember, the baby stays.
Oh, cosine of 5x parentheses times 5.
Yes. How do I clean that up? How do I rewrite that? To make it look prettier.
Would it be 5 cosine times 5x?
That's how you write it, but I just want to be a little bit careful on the vocabulary that you used. You said an extra times in there, so just be careful on that part. So it's 5 cosine of 5x. All right. I do get a lot of students that think it's cosine times 5x. So just be careful. You kind of did both. You said of and then you said times. The of is correct. The times is not. So it's 5 times cosine of 5x. So just be careful on that one. I mean, we want to make sure that we're getting that, because what happens for a lot of students is I'll get students that do this. They'll go, oh, that's 25 cosine of x. No, because they'll think about that times in their mind, and they'll try to do, oh, okay, so then I can just bring the 5. No, that doesn't work that way. A 5x, and as I was telling you about chain rule, if you see the baby in the problem, you see the baby in your answer. Of course, the question goes, that was brought up, how do I know it's the baby? Well, it's of. Whenever you have to say the word of, the square root of all of this, or all of this, when you say all of this, or, all to the, you use the parentheses to the, and you have multiple things to the power, all this times, that's chain rule. F of x. Now, before you, I want you, everybody in here, to try to write down the answer, and if it's wrong, cross it off, but write it down. If you're not attempting this next one on your own paper, it's not going to be beneficial. The next one is cosine of x squared. Please write down what you believe the answer to be. I'm going to give we'll give it just about 30 seconds, and then we're going to go in, but please write it down. Write what derivative is. All right. F prime of x equals?
I thought it was negative 2x times cosine of x squared.
Almost. I think you had it right, even when you did that negative.
It's positive 2, right?
No, she's right at negative. She's right with the negative. Now for you to jump to, she gave me the final answer, in its cleanest form.
It's sine.
Sine, yes, of x squared. So remember, it's going to change. So there's a lot of things that can go off in your head that are like alarms, and we can only learn them by practicing and making mistakes. And mistakes are good in calculus. Coming in and going, oh, and then you're like, oh no, that was wrong. And then when you do it later on, the next time, you have to build those like wee symbols that just go off in your head. It's like, oh, I did something wrong. Oh, yeah. So if it's cosine, it's going to change, unless it's part of like a product rule, or it is the baby itself. The cosine will change, because the cosine, the parent, the mommy functions always change. That's what we should know. If mommy's a trig, she's going to change herself, okay? Now, some of you might have done negative sine of x squared times 2x, and then you can get to this answer right here. All right, but, so it's negative sine of x squared times 2x. Well, let me just bring that 2x to the front, just to make it look a little bit cleaner. And that's how you would see it on your paper. Negative 2x sine of x squared. E. F of x equals negative 2x sine of x squared. This is the same thing as me saying if I asked you for the second derivative, remember we talked about those higher order derivatives, you want to take the derivative of the derivative. But let's say what we got, in essence, we're finding the second derivative of cosine x squared. So now we're getting a little bit more complicated here. How do I take the derivative of this function? Before I actually do it, let's talk about concept-wise. What type of problem is this at its forefront? What is the main type of problem? What should you be thinking of first? And it shouldn't be trig.
Is it product?
Yeah. This is a product rule. U prime V plus V prime U. Okay? So, as such, I'm going to state that this is my U and this whole thing is my V. All right. If you feel comfortable going directly to the derivatives and writing, and going right to f prime of x equals, please do.
Negative 2.
Hold on. I'm not asking for an answer yet. If you feel comfortable going directly to it, then do it. But a lot, especially in your infancy of learning this topic, you're most likely going to make a mistake. The most likely mistake that you're going to make is what? What is the number one bad calculus student that will do? What will they do? How many terms will be in my answer?
4.
There'll be 4 terms, yeah. 4 terms and 2, 4. There'll be 4 terms. There's 2 terms, right? There's going to be 4 because you're going to have a plus. The biggest mistake I'll get with students is they're going to say negative 2 times cosine, and they'll say cosine. I'm just like, ooh, you're already off. You got to have that plus. So if you can, and you should, especially in your infancy of learning this, find u prime on the top, which I heard from Darwin, negative 2. And what's v prime?
Cos x, no, cos 2x.
Cosine.
No, yeah, cosine.
But it's
2x.
not. No, it is not. Got to be careful. We got to use the same properties we've just learned. What's the derivative of v? What is v prime? I like doing these little parts on the side because it try to says you don't even have to look at the negative 2x. Block like the negative 2x isn't there. What is v prime?
Is it cosine? Wait, no. It should be 2x times cosine.
Yeah, I'm gonna for the purposes of doing it for the lecture notes. We won't clean it up till afterwards.
Okay, so it's cosine of x squared times 2x.
Yeah. Biggest no-no in calculus with chain rule. There's 2 no-nos for product rule and quotient rule, right? There's a no-no for product rule, a no-no for quotient, and a no-no for change. The no-no in product, the bad calc student, is you just take the 2 derivatives and you multiply them. The bad calculus student sees a division problem and they just take the derivative of the top over the derivative of the bottom. One term, one. You started with 2, you end with 2. No. And the bad calculus student, when it comes to chain rule, is that they'll take the derivative of what is inside. These are all things that when you do it, and I do it all the time. I'll do it because I haven't done derivatives in so long, and I just get into a groove and I'm just flying through problems, and I'll do it. And you might even see me do it on an example that I'm working with you. But one of the things you will notice that I do every single time is I'll go through the problem and then something goes off in my head and I go, uh-oh. And I go back and I fix it because I realize that it doesn't make sense. Something is like, I got that spider sense. It's the calculus sense that you get. And if you want to, and I hope you do, and I hope you feel comfortable writing this as cosine 2x cosine x squared. So, what is f prime of x? What is f prime of x? Let's put it together now.
The negative 2 parentheses. Sine of x squared plus 2x cosine of x squared negative 2x.
There we go. U prime v plus v prime u. Now, of course, you want to clean that up, but that is the answer. You can put that into delta math. It'll give you like, we want to clean it up. Negative 2 sine of x squared minus 4x squared cosine x squared. And just multiply the 2x times the negative 2x. Example. Oh, sorry, an example. We're on F. Trying to get as many examples as I can. F of x equals the square root of tangent of x. What do I do?
Make it calculus friendly.
Boom. So this is the same thing as what?
Parentheses, tangent of x to the power of 1/2.
Perfect. Okay. So how do I take the derivative? Now, what is the baby?
The tan x.
The tangent of x, tan x. Tangent of x is the baby. What does that mean about my answer?
Is that second square?
What does that mean about when I look at my answer? Wait, I know we're right at time, but I'm going to... Well, your chain rule, you're going to see tangent of x in the answer. So I'm going to move forward in this one. So I bring the 1/2 down, and then what? What do I got inside?
It'll still be the tangent.
Yeah, that's the most important thing I need to make sure that you have. It's still the tangent. To the power of?
Negative 1/2.
Perfect. Times?
Second square.
Secant squared of?
X.
Of x. We'll do more examples tomorrow. We'll start plugging them in, so we'll have a lot more example problems tomorrow. I didn't do ones where the derivative of, tangent of like 5x, but that would have been like secant squared of 5x times 5. There's so many different examples that we can do. I hope you're feeling that, hey, I'm just using the other rules, and I just got to make sure that I'm using them correctly. When I use the chain rule, I use the chain rule correctly. When I do the product rule, I use it correctly. When I use the quotient rule, I use it correctly. When I use the power rule, I use it correctly. Use things correctly. Calculus can be the derivative work is rather one of the more directly straightforward terms, because there's not much thinking beyond. I know a rule, I apply a rule. I'll see you tomorrow.